Hello guys, and hello everybody. We want now to review some rules about the kinetic and the work and energy lessons. That's want to review it and use for this lesson. Let's start with it. Now we can use this rule. The first rule is what and W equal F times D type cosine alpha. The cosine alpha we can use in case of a translation. Here is the symbols and the units of every force and every from this working energy. Then we have here alpha and the passes here play a role. Let's begin with the first one. First one, it's an alpha between 0 and 90. The cosine alpha equal greater than 0 if we have alpha between 0 and 90 in this path. Here, work is greater than is a motive for work. And these are the F1 of forces, and these are the force make an alphabetic. If alpha between 90 and 180, cosine alpha is 0 less than 0 and W less than 0 resistive work. Also here we can write that if alpha it's between these two values, and if alpha equal to 90, cosine alpha equal to 0, because here the pass make an zero action reaction. And if alpha equal to 180, cosine alpha equal to -1. Here the last one is n W of mg equal W of n equal 0 perpendicular path. That's right path here away is n path of n pi over 2, it's a 90 degree over this path. Here in case of translate, in case of rotation, in case of rotation and work equal momentum times theta is an rotation part. Where is the rotation? Rotation, what is mean by when you draw a circle, that's the theta play a role in this circle, in this figure, and we use only in rotation part. Momentum equal to F times D. F is a force that we can use to calculate its forces like weight, like normal, like and friction, like and forces of force of engine, like many forces of usement, and times the distance. These two we calculate to maintain and to calculate momentum of an rotation parts. Distance between forces. Here angular abscissa here, and the power it's a work in an unit of time that we can calculate. In translation, power equal work over time. Here in case of translation, we can put that the power equal work over time. But focus in this point. Work here, if we make a deprived to this, work equal F times D times cosine alpha. Here guys, these are the rules that we put in, power equal this, and power equal to force here make times D over T. V here we maybe put V here, V equal to D over T. D over T we make here and times cosine theta, and here we put, because D over T we put V here and times cosine theta is, and the last rule for power we can use in translation apart. if the power is an rotation, you can use power momentum times theta, like here work momentum times theta. Here is a power momentum times theta prime. This theta prime is angular speed. Theta prime not like theta. Theta is an position part. Theta prime is an speed. Like here we can put here, focus here. We can put in this is an x, and position. But here we don't put in an rotation part is an v, because we make an derivative to an theta to an x, we make a theta prime that's equal to v in translation. But here in an rotation part put an theta prime that's equal to an speed, and here theta prime is angular speed. For now we can measure by a radian per second. Here is the energy. Anybody to do work process energy, and because we use friction we make energy and we make work lose some of an power or lose for this energetic part, and kinetic energy is equal in and translation have mv square, and in an rotation kinetic equal half I theta prime square. Theta prime we deduce it as an angular speed of radian per second. Here in rotation we can use, and here in translation. But here is some note we can use our theorem of work and energy. The variation of a kinetic below and between two instants to the sum of work done by an external forces. يعني delta of kinetic equals sum of n w of external, يعني sum of n w equals sum of a work done by force. يعني here we can put that's what the delta of n kinetic equal to sum of w of forces. Here are the work, the theorem of work energy parts. We can use this rule. Here guys is potential energy, elastic, focus in elastic means by a spring